Lesson 6.g.3 is about drawing polygons on the coordinate plane. So your vocabulary today is first polygon. Polygon is a two-dimensional shape. That means it's flat, not 3D, made from straight line segments. It's triangles, squares, octagons, hexagons, dodecagons, things like that. A vertex is a corner of a polygon where two line segments meet. So a rectangle has 4 vertices, which is more than one vertex, and those are the corners. Okay? So a hexagon would have 6 vertices. All right. Our notes. To draw polygons on the coordinate plane. First, plot the vertices. Remember, the first number in an ordered pair is the x-coordinate, and the second is the y-coordinate. Then you connect the vertices with straight line segments. All right, so our example. A square is drawn on the coordinate plane with vertices at 2, -3, 2, 1, and -2, 3. What is the location of the 4th vertex? So we're going to need to look at the coordinate plane. I'm just going to sketch one. And we're going to plot those first 3 vertices. So 2, I'm doing this one right here, 2, -3. So the first number is how far you go across on the x-axis. And the second one's on the y-axis. So 2, -3 would be right here. Over 2, down 3. And 2, 1 would be over 2 and up 1. That would be right there. -2, 3. -2, 3 would make it a very difficult question. So we're going to change that 3 to a -3. -2, -3. And now I'm going to try to line this thing back up. Okay, so it's -2, -3. So -2, -3 would be backwards 2 and down 3. And what's the location of the 4th vertex? Well, the 4th vertex is going to have to go here, and it's going to have to line up with this vertex and this vertex. So it's going to have to be 1 above the x-axis and 2 behind the y-axis. So it's going to be at -2, comma, 1. Okay, so that's our answer right there, -2, 1. All right, extra examples. So we've got 5 vertices of a hexagon are shown on the coordinate plane. Which point could be the 6th vertex of the hexagon? So I'm thinking this 6th point must just not line up with those other ones. So -3, 4. Let's go ahead and plot each of these to see if they would work. I need to quit drawing on my shape here. Oops. Okay, so let's go ahead and plot -3, 4. -3, 4 would be backwards 3 and up 4. It would land right in line with these other points, and that would not make a hexagon because it would be on that line. Okay, so that would still be a pentagon. All right, so that one doesn't work. I'm going to take those points off and cross out that option. -3, 5 would work because then if you connected the points, you would have a hexagon. So that one works. Are there others that work? Is this the kind of question that has more than one answer? I don't think so. It said which point. I think there's only one answer. I'm going to check to make sure the other ones don't work. -5, 5 would be in line with the first points. That would not work because you would line up with those 2 vertices there. What else do we have? So that one's out. Negative 1, 6. Negative 1, 6 is going to line up with some other ones. You would end up here. You'd end up lining up with two other points. That would not make a hexagon. The only one that actually works is negative 3, 5. All right. The following points represent two vertices of a triangle. Determine whether the following points could be the third vertex. So, like I was saying before, I just need to make sure that none of those other points are lined up on the y-axis in this case, because that wouldn't make a rectangle or a triangle. So I'm thinking anything that has something other than 0 for the x. So I think 3, 4 would work, because 3, 4 would be, it's hard to write on a small graph. 3, 4 would be right there, and that would make a triangle with those first points. And 4, 7 would work, because 4, 7 would be up here. That would also make a triangle with those other 2 points. But the other 2 points, okay, these points would be lined up with the red dots. So those are no's. Everybody knows those are no's. See what I did there? And these are yeses. Okay. Next question, part 1. Cindy left her home to go to her school. After her school, she went to the bookstore and then to the bakery before returning home. The coordinate plane shows the locations of Cindy's home, the school, the bookstore, and the bakery in her town. What are the coordinates of her home? Okay, so her home is right there. So it's over 1 and up 0. So her coordinates are 1, 0. So let's hope that that's one of the answers. 1, 0. Right there. Part 2. If you connect the points on Cindy's travel, what's the area of the shape created? The area of the shape created is a 4 by 4 square, and 4 times 4 is 16. There's 16 square units. So, correct answer, right there. Time for your quick check. Good luck. See you soon.